be showing you the physics behind hurdling.
Everything from your projectile motion
to your momentum.
and everything in between.
Let's get started! Hurdling is an event in track and field in which many physics concepts can be applied to numerous aspects of the race.
Speed is a scalar quantity that refers to how fast an object is moving, while velocity is a vector quantity that refers to the rate at which an object changes its position.
The more you swing your arms and bend your knees, the faster you will go.
A runner must reach maximum velocity before they jump over the hurdle. Faster before you jump equals a faster jump, which results in less time taken to clear the hurdle.
Another thing that runners need to take into consideration is to keep legs as close to the body as possible. This will equal less air resistance, which will allow for a more constant speed throughout the race.
After clearing the hurdle, speed is lost, so you need to re-accelerate in order to clear the next hurdle.
Friction opposes the sliding of two surfaces across one another. Friction acts opposite to the motion or attempted motion.
The simplest way to increase friction is to wear track spikes. The spikes increase your friction, which will increase the amount of force you need in order to push your body forward and over the hurdle. If your friction and force both increase, then you are able to sprint between the hurdles and clear each one much quicker.
We will now show you two examples of how the friction that the track spikes produce allows you to run faster and clear the hurdle more quickly.
The person that was wearing the track spikes had a much easier time clearing the hurdle and was able to run much faster.
A projectile is an object in freefall with horizontal motion in addition to vertical motion. Projectiles follow a path of a parabola.
In a hurdle's projectile motion, the velocity, acceleration, and displacement in both x and y directions are linked by time because they have the same time interval throughout the motion.
Runner needs to make sure they jump at a specific angle, which is usually in between 60 and 70 degrees, in order for them to clear the hurdle in the shortest amount of time.
This angle going into the jump is the same as the angle coming out because the takeoff point and the landing point are on the same level.
This next example shows how hang time is bad. You must make sure to reach a height over the hurdle, but not too high that you gain hang time and gain seconds. Momentum is the quantity of motion of a moving body, measured as a product of its mass and velocity.
As you're sprinting between the hurdles, you will have a high amount of momentum. Your speed is increasing in relevance to your own mass.
This means the heavier you are, the more momentum you have, and the less control you have over your body.
This next example shows how momentum really does affect hurdling.
As you can see in the second example, this person had a much higher mass, which caused them to have a higher momentum, making it harder for them to control their stop.
Momentum is very important in hurdling because you need to be in total control of your body, and not being able to stop due to too much momentum does not give you any control.
Newton's third law states that every action has an equal and opposite reaction. Right before you take off to clear the hurdle, your foot digs into the ground. This downward force being applied through your foot is the action force. Jumping over the hurdle and the motion of your body moving up and over the hurdle is the reaction force.
If you know your projectile motion, speed, friction, acceleration, and momentum are all good, then you can avoid this.